So I'm putting together this Edge 540T I got from, I believe, banggood.com, and I've slid the wing into the fuselage there. You can see it's on mid-wing 3D plane. And I just want to make sure I get the symmetry right for the wing in relation to the fuselage before I actually glue everything in place. Now in this particular model there are these sort of helpful indicator arrows that point to a line along the wing where the design is, but that is, I don't really trust that, because to me the true measurement of the more accurate symmetry for your wing is always going to be in relation to the fuselage, not some sort of marker on the wing that the manufacturer may put in, which itself may already be inaccurate depending on the precision of the manufacturing process. So there's some obvious measurements here what we need to concern ourselves with. One is the distance from the fuselage to the wingtip on one side, which should of course be equal to the distance on the other side of the wing. So we're going to do that. We could also, there's obviously the joiner here for the wings, but in this case it's a little bit difficult to actually measure the distance between here and here due to the way the fuselage is formed. But I'm going to essentially use these measurements from the fuselage to the wingtip. That's my first one. And I'm also going to use the angle between the leading edge and the fuselage. So this is when this handy tool comes in, which is a sliding bevel, and I recommend everyone has one of these. Essentially what it enables you to do is to choose an arbitrary angle to lock it in place, and then you can do some comparisons. So what I could do is, I'm just moving, this is just for demonstration purposes. So basically if I lock in the angle there, then I flip it over and I do the other side, the angles should be the same, right? And of course I've got to make sure that this is flush, the bevel face is flush with the fuselage, but you get the idea. And I can also do this on the trailing edge, and I'll probably do both of them because there'll be some variances no doubt in the manufacturing process. So as you can see, I'm just basically making the bevel as flush as possible with the surfaces, and then flip it over, oops, and compare it on the other side, and I'll do that until I'm happy with the symmetry, and then I'll glue it in place. Thing to note is these bevels often come with themselves a beveled edge there, and that's fairly sharp, so you can ding it into your modeling, so you've got to be careful with that. But yeah, this is just a fairly cheap, as you can see the brand is Fuller, sliding bevel. Of the models that you can get, some of them have like a screw, a turn screw with some knurling on the edges of it. I don't like those because I prefer these wing nut designs, because it's easier to actually screw and unscrew, and also if you happen to lose a wing nut, they're easy to replace. Wing nuts are a very, very generic fastening item versus a custom, a bespoke knurled tuning wheel. If you lose that, then you're going to have to replace it with a wing nut. So why not just get it with a wing nut from the outset? So I mean, you could use this tool actually, the sliding bevel, on tail surfaces as well. Any surface that requires some symmetry in terms of angles, and it's an unusual angle that a non-adjustable, non-variable angle tool won't provide.